And this is a marine 3D printed foiling board stabilizing drone or something like that.
You watched for sure my previous video about building an hydrofoil for a laser. That foiling system was actively stabilized just in the heave motion through a mechanical system that senses the height of the boat from the water surface. The rest of the stability is managed just by the sailor that controls row through sail and weight adjustment and pitch by just trimming manually the rudder foil. Then I thought, I drive drones. And they are not intrinsically stable because they just rely on these 4 motors. But they actually are stable. And so, how? If you've ever wondered how drones stay stable in the air, execute precise movements, or respond instantly to your controls, the flight controller is where all the magic happens. A flight controller is essentially a small onboard computer packed with sensors like gyroscope, accelerometers, barometers, and GPS. These sensors constantly monitor the drone's position, speed, and altitude. The flight controller takes this data, processes in real time, and sends commands to the motors to adjust their speed and keep the drone balanced and responsive. In the case of plane, it sends signal to the control surfaces. Now you might be wondering, how does this relate to foil boat? Well, here it gets exciting. The same principle that stabilizes a drone in the air can be applied to a foil in the water by building the foil system with controllable surfaces. So now I can test this concept in a fast and affordable way. The best way is to build a model to validate this idea, to learn and understand how all of this works. I took the design from RCtestflight. There's so much genius in this approach, and I completely redrawn it, changing wing profile but maintaining the same concept. And so, what exactly is this model? Think of it like a plane that operates underwater and lifts whatever is on the top, reducing drag and increasing velocity. This model is equipped with ailerons for row, elevons for pitch control, and rudder for yaw. The flight controller ties all of this together, making real-time adjustment to keep the system stable and efficient in dynamic water conditions. Now let's build the real thing, starting from a lot of 3D printing. I printed the 2 wings with the Bamboo Lab in PETG and the 2 masts with the FL Sun in PLA. And after almost 1 week of print and fails, I got the main wings. All the sections are joined together by carbon and fiberglass rods. Then some polyurethanic glue bonds together the plastic surfaces to the rods. I used 8mm unidirectional fiberglass rods for the wing and 3, 4 and 6mm for the tail. The polyurethanic glue bonds the prints together and foams up a bit. It can be removed with a razor blade. Then I continued gluing the sections together, wiring up all the connection for the servo motors. 4 servos are needed, 2 for ailerons, 1 for elevon and 1 for the rudder. Each servo needs 3 wires, 1 for the ground, 1 for positive 5 volts and 1 for the signal. I had to cut the servo wires and solder them together to make them waterproof. The 2 aileron servos are aligned with the circular hinge of the aileron and directly connected to it. And then I print some covers to silicone that up and make it waterproof. After making the servo waterproof, actually not a simple task, it was time to make a floating board.
Can use this flotation device. What they say, they float.
I took my favorite knife and I started shaping a simple XPS insulating board. The only purpose of the board is to maintain buoyancy and stability when the drone is not foiling, therefore in this model must not be too complicated. I milled the slot in the XPS to insert a connection between the masts. Then I inserted the masts and passed wires and prepared a waterproof box for the electronics. Now it's time to wire the electronics, starting from the flight controller, soldering everything together, the ESC for the motors, the receiver, and a bunch of other components. I tested the motors before in the water, and yes, they make a lot of thrust. And now discovering if everything will explode. Here you can see how the flight controller reacts to the external accelerations in roll axis, pitch axis, yaw axis with the rudder, and also with differential thrust. Then there is some time to spend in front of the computer, configuring outputs and mixing the channels. There's also the part of PID tuning that is crucial. The PID means proportional, integral and derivative, and it is an algorithm that is based on 3 parameters to control a system. The proportional reacts to immediate errors, the integral corrects from long-term drifts, and the derivative predicts and smooths sudden changes. Just some time to tune that and we are ready for the first test.
Questa è tipo la checklist.
Perfetto!
Mi sembra che...
Dai, è stabilissimo!
Okay, I forgot to tie the screws of the watertight box and I fried everything. But come on, it worked at the first time. Time to think about it, change some component and back again. This time in a better location, I had a bit of a problem to calibrate the accelerometer on the boat and I started from land again. And like magic, boom! It flies like a champ.
La 3 per!
I then tried to lift 2 kilos and no problem. Finally went big with 5 kilos and no problem either. It felt definitely heavier, but it still manages to exit from water. There is a lot of power still. Cruising at a speed of 5-6 knots. I then tried doing some simple math to see if I could predict the speed and the angle of attack of the foil. Using X-foil, I compute the lift and drag of the model, adding the drag of the motors. This wing is made for low speed, making a higher aspect ratio wing would increase maximum speed of the foil. So knowing the thrust of the motors, estimating a resistance, math seems to make sense.
Stabilissimo, stabilissimo. Cioè, l'ho spinto. Sì, sì.
Here we did a test in high waves, and many went through. And now I leave you with some FPV shots. That's all for this video, hope you like it. It's just the beginning of new projects. Consider subscribing. Ciao.